Hi everyone, this is Soumyadi Paul, a mentor at CodeKerdos and a software developer at Amazon, and welcome to day 17 of our DSA series. Now in this video, we will be learning something called as insertion sort. Okay, now what is insertion sort? Till now we have learned what is bubble sort and what is selection sort. Those are two great sorting algorithms. Now we will be learning our third sorting algorithm, which is insertion sort. Okay. So let us understand what insertion sort does. If you remember, in bubble sort, what we used to do was we used to swap elements from left to right, and we used to swap if the larger element is on the left. So our goal was to shift the larger element to the right. And in that way, first we used to shift the largest element to the last position. Then in the next iteration, we used to shift the second largest element to the second largest position. Then the third largest element to the third largest position, and so on, isn't it? Here in insertion sort, we will do the reverse. We will move the smallest elements to the left. Just like bubble sort. But what we do is we move the smallest to the leftmost position. In the first iteration, we will move the smallest element to the leftmost position, then second smallest element to the second leftmost position, then third smallest element to the third leftmost position, then fourth smallest element to the fourth leftmost position, and so on. Okay. So very simple. We will start from this. Okay, suppose this is my array. Here I have some boilerplate code. I have the main function. I have a sample array. I'm calling the insertion sort function. I'm expecting that I will write the code in this insertion sort method to sort this array. Then I am printing this array to check if my sorting function works fine or not. Okay. So what we'll do here is we will have a for loop which starts from the first index, Okay. We will start a for loop which starts from the first index. So now I will start here from the first index, I is equal to 1, I less than arr dot length, I plus plus. Okay. Now inside this, what my task will be? Inside my outer loop goes from 1 to last. Okay, so what does my outer loop goes? My outer loop goes from 1 to last. Okay, by incrementing I. And my inner loop goes from I minus 1 to first, or I can say 0. First is 0. Okay, to first, to 0, by decrementing it. Okay, here by incrementing, here by decrementing. Outer loop is I and inner loop is j. So inner loop goes from I minus 1 to 0. Okay, inner loop goes from I minus 1 to 0. Okay, and what will I do here? My job is to compare the ith element. With the jth element. Okay, this is I and j starts from here. My job is to compare the ith element with the jth element, and if I is if this is smaller. Okay, if I is smaller, then I will swap it. Okay, if I is smaller, then I will swap it. Okay, so what I need to do is I need to check. I will start from j is equal to I minus 1, and I will check the jth element and the next element, which is j plus 1. Okay, which at the first time will be I. So I will check these two, and if the j plus 1th element is the smaller one, I will swap them, because here my goal is to push the smaller elements to the left. Okay, in bubble sort my goal was to push the larger elements to the right. Here in insertion sort my goal is to push the smaller elements to the left. Okay, so what I'll do is I will also have another function. See, we should always write modular code. Our code should be as modular as possible. Okay, so I will create another function which will be doing a swap. Here I'll pass an array and two indices. add of A and add of B, and add of B is temp. Okay, done. So this is my swapping function. Here what I'll do is, if ARR of j plus 1, if this is less than equal to ARR of j, okay, sorry, greater than equal to. If it is greater than equal to, then it's fine, then it's completely fine, okay, it's completely fine. Okay, then it's completely fine. But else, if it is not, if the next element, the element to the right of it is smaller, then I need to swap it. Okay, done, I need to swap it. Okay. So this is what I want to do. So now if I run this code, okay, there is some error. What is the error? Oh, my bad. This is a static method. I cannot call non-static methods. So these methods should also be static methods. Okay, see? Bingo. Perfect. My array is completely sorted. So see? This is insertion sort. Pretty simple, isn't it? Pretty simple. Our entire goal is just to keep on swapping so that I can push the smaller elements to the leftmost position. Okay, so in the first iteration of I will push the smallest element to the leftmost position, or the first position, I can say. In the next in the next iteration, what I'll do is I will push the second element, the second smallest. Okay. So in a way, what I'm doing is I'm trying to keep them sorted. Okay, see, first when I is equal to 1, I is here, I will be swapping them, so my array becomes something like this. 1 4 3 9 6 2. Now this portion gets sorted, and this is my unsorted portion. Okay, unsorted portion. And this is my sorted portion. So in a way, now I'll move I will come here, I is equal to 2. So now I will try that this next element in the unsorted portion should be pushed left side into the sorted array and pushed it to its right location. Okay. I cannot say exactly like bubble sort, because in the bubble sort I am always pushing the largest element to the right. But here in insertion sort, I am pushing the elements from the unsorted to the sorted area in its correct position. Now see, 3 is bigger than 1 but smaller than 4. So 3 should come between 1 and 4. So I will first swap them. It will become something like this. 1 3 4 9 6 2. Okay. And then I will not swap again because 3 is already larger than 1. So now you can say that this entire thing is sorted, and this half is unsorted. So you can visualize it like this, that I am having a sorted array and an unsorted array, and my motive is to push the first element, of the unsorted array in the correct place of the sorted array. Okay, in the correct place of the sorted array. Okay. This is what we do. This is the logic. Okay, this is the logic. And what is the algorithm for this logic? Pretty simple. We start the outer loop from I to end. We start the inner loop from I minus 1 to 0. And we just check if the element pointing at the inner loop is smaller than the next element, then it is fine. Otherwise, I will swap it. Okay, that's it. This is the logic. This is the algorithm. Okay, pretty simple. I can even shorten this code. I can just say if this is less than, if it is less, then write this. Okay. I don't need this else condition anymore. If I run this, it will still work perfectly fine. Yes, it is working perfectly fine. So see, just 4 lines of logic, just 4 lines. See, just 4 lines of logic. Pretty simple, isn't it? Okay, so that's it. So I hope you all have understood what is insertion sort. Try to code it by yourself as well. And I'll see you all in the next video on our next topic of data structures. Okay. See you everyone. And if you want to learn these algorithms, or if you want to ask doubts or practice these algorithms straight away from the top coders of big product based companies such as Amazon, Google, Microsoft, then do join CodeKerdos.